Let me hit record and minimize, and then let's see if we can get 72 up here. Alright. 72, we have x plus 5 plus x plus 2, x minus 2, excuse me, all divided by x squared plus 2x minus 15. We know we're going to have to factor that, plus x minus 2 times x minus 3. Alright. First of all, let's factor the bottom left. What's that factor in?
So it'd be 15. So, 3, negative 3 and 5.
Negative 3 and plus 5. So that's really what we're looking at. Whenever you can factor, you should. Now, the top just needs combining. What do you get when you combine the top?
2x minus 10.
Actually, it's just adding, so it's 2x plus 3.
Okay, got it.
In other words, I'm adding the plus 5 and the minus 2. Okay. So now I have this thing at the bottom here. Hold on a second. So, this is kind of an odd problem. In other words, there must have been some reason they had us factor the bottom. Okay, I can kind of see it. Sometimes you just have to proceed with these problems until you see the answer. Well, the bottom, I can factor out an x minus 3. You see how I can do that?
Mm-hmm.
Okay, and what's left over is an x minus 5 plus an x minus 2. And notice that this term right here becomes 2x plus 3. In other words, if I simplify that, I've got 2x plus 3. Now I've got a 2x plus 3 in the numerator and a 2x plus 3 in the denominator. Everything's being multiplied, so cross those out and I end up with 1 over x minus 3. That's my answer.
Awesome.
So a lot of times these problems you just kind of have to factor and simplify. In other words, factor and take down to its lowest process, or its simplify. Let's look at 73. Well, 73 looks really complicated, and there's a reason why it looks this complicated. I think. Let's simplify and see what we are looking at. Now, the fact that it's all over h. This is your first glimpse of calculus. This is kind of a calculus problem. Okay? Now, the goal is really simplify everything and see what we got. What's the top become?
Ooh, okay, so...
Well, let's expand that.
Okay.
What do we get?
So it's just x plus h times...
No, it's x plus h times x plus h, correct. That's x squared plus 2xh plus h squared. That's what that thing is equal to.
Okay.
Now let's distribute the 5, so that becomes 5x minus 5h. Takes care of that. Now let's remove those parentheses, so we have minus x squared plus 5x. See why that's plus 5x? In other words, I've got to distribute that negative sign to both terms.
Yeah.
So I end up with a minus x squared minus 5x. Okay, so I have simplified that. And now, what do we have? Well, let's look at our x squareds. What's our total x squareds?
Do they cancel out?
Yep. In other words, 0. What's our total x's?
-3. Wait, just 2x.
Well, hold on. We got minus 5x there, and we got plus 5x there. Cancels out.
Oh.
In other words,
So the 2xh is like one
no,
thing?
that's an xh. This is an x. Okay?
Got it.
So now what we're left with in the numerator is 2xh plus h squared minus 5h. That's it. Now what's in common with those three terms in the numerator?
They all have h's in them?
So let's factor an h out. That's going to be valuable because I have an h in the denominator. So that's what I get in the numerator when I factor an h out. Have the h in the denominator. Because the numerator is h times this, then I can cancel the h's, and I'm left with 2x plus h minus 5. That's my answer. All right. Let's look at 74. Now, the moment you look at 74, you should see that it's a factoring problem.
Okay.
Okay?
Oh, yeah.
Yeah, in other words, we've got a very complicated numerator and denominator. They're both quadratics. Actually, the numerator is a cubic. So if we can't factor it, then we got nowhere to go on it. So we better be able to factor it. Let's start with the left side. Only because I don't have room to write the whole thing. So let's try to factor. Can you take a greatest common factor out of the left side? The top left.
Oh. X.
Okay, what are you left with?
20x squared minus 56x plus 15.
Okay, now that's a standard quadratic. Not going to be able to take a greatest common factor out of that, but I can probably factor it. About the bottom, is there a greatest common factor in the bottom?
2.
Good. Always take the greatest common factor out because that means whatever's left is more easily factored. Okay. Now, rather than attempt to factor the top, which probably can be factored, but it's a very difficult quadratic to factor. And I don't, well, maybe there's an x plus 3 comes out of that. Maybe. Let's factor the bottom first. The reason that's useful is because the bottom I can factor pretty easily. It's x plus 3 times x minus 2. Okay? Now, the top, the odds are one of those factors is going to be what I see in the bottom. And it certainly isn't x minus 2, so let's guess that it's x plus 3. What would the other factor be? If one factor of this quadratic is x plus 3, what's the other one?
5.
Hold on, the first term would have to be 20x, because these two terms need to multiply to 20x squared.
Okay.
And the next term, these have to both be minuses. And is that going to work?
No.
No. In other words, that produces the 20x squared and the minus, or the plus 15, but it just barely misses the middle term. So that top term does not factor the way we would like. So, let's see, what can we do? In other words, well, maybe that isn't supposed to factor. In other words, let's leave it as a quadratic and do the rest of the problem. In other words, there's still more on the problem to do. It's times 8x squared plus 4x minus 40 divided by 8x to the 4th minus 50x squared. When you see problems like this, know that it is all about factoring. There's nothing else going on here. Okay? We're going to factor everything as much as possible, and then we're going to cancel stuff. Lots of stuff. All right, so let's start with that. How does that factor? Take a always start factoring by a greatest common factor.
And that would just be 4.
Okay, so that's 4 times 2x squared plus x minus 1. How about the bottom? Take a greatest common factor out of that.
2. Oh, the bottom, just kidding.
2x squared.
Yeah, 2x squared.
That's going to leave 4x squared minus 25, which is a difference of perfect squares. Wow.
Okay.
My problem is that my chalkboard's not big enough. So let's see if we can rewrite this. I still think that probably factors, but let's not worry about it yet. I'll write it as a quadratic and put the bottom over it. Notice that when everything is factored, it's much easier to simplify. That's why factored answers are always better than unfactored answers. Now, does that factor into, yes, it factors into 2x minus 5 times x plus 2, only I got the signs wrong. It's x minus 2. In other words, that produces that quadratic. Okay? Divided by 2x squared. This is the difference of perfect squares, so that's 2x minus 5 times 2x plus 5. Okay? Now we're looking at this. No addition. Everything is multiplication, so any place that I can cancel, I want to. Well, I see an x minus 2 there and an x minus 2 there. I see a 2x plus 5 and a 2x plus 5. And I see a 4 and a 2 and a 2. So, what does that leave me with on top? It leaves me with this. And on bottom, leaves me with, I got an x plus 3 over here, and I got a 2x minus 5 there. So I'm down to this bottom term. Now, I have an idea of how that might factor. What do you suppose one of the factors might be of that? Something that's in the denominator, right?
Yeah.
In other words, I just know that one of those factors has got to be what's in the denominator. Well, let's see. Let's try 10x and 2x minus 3 minus 5. That works. Notice that 10x minus 3 times 2x minus 5 gives you this quadratic that's in the numerator. In other words, that gives you minus 6x. This times that gives you minus 50x. I get the middle term of minus 56x. More importantly, now I can cancel that 2x minus 5 with that. And now what am I left with? Here, let me go scroll down a little bit more. Leave everything in factored form because you never know when it might cancel. So it's better in factored form than not. Bottom's got that. That looks to be as good as you can do in terms of simplifying it. Can't factor anything out from the top. Can't do anything else with the bottom. And I cannot cancel anything. In other words, there's no way to cancel that x with that x or anything else. So this really should be the answer that's given at the bottom of the page. Now you might say, well, should we multiply the top together so that we get this? And I'm guessing no, we shouldn't. Again, factored form is better than unfactored form. Let's take a peek. 74. (10x minus 3 over x times x plus 3). Well, I must have made a mistake in my math. I must have had an x there. And in fact, I must have had an x squared there, because that x cancels with that, and you end up with this as your answer. Or at least they ended up with that as their answer. Which means I must have made a mistake somewhere in doing the problem. And that certainly happens, especially with problems like this that are this complicated. So, I don't know what to say. I'm looking at a problem here, 74, where I can tell there's at least 6 steps involved. And a lot of factoring, a lot of dividing out greatest common factor. So there are a ton of places to make mistakes. Obviously I made one. It's not going to be worth going back and figuring out where I made my mistake. Let's just take their word for it. I know my process is proper. So let's go on to 75.
Okay.
Again, 75 has a quadratic in the top left, a quadratic in the bottom left, a quadratic in the top right, and a quadratic in the bottom right. So my solution is going to lie how? What am I going to do to solve this?
Factor it.
Okay. Fact, always just start with the top left. Do as good a job as you can with factoring that.
Okay. So, let's see.
Split up the 5x squared. There's only one way to split that up.
2 and 3.
No. You got to multiply.
Okay, so 5
2
and
and 3 would multiply to 6x squared. But 5 and 1 multiply to 5x squared. That's the only way to split it up. There's no other way to split up 5x. Okay? Now, my signs have to be plus minus, but they could also be minus plus. They won't necessarily result in the same answer. Well, factors of 12. 4 and 3 works really nice. 4 there and 3 there. Notice that produces this middle term of minus 17x. That's what we want to do. When you're factoring, a lot of it is just trial and error. Okay? And that's kind of what I did in my head, was I did some trial and error to come up with that. I knew that I had to produce minus 17x as a middle term, and if I add 3x plus minus 20x, I get minus 17x. So I factored the top left. Now factor the bottom left. How's that 5x squared split up?
5 and 1.
Well, 5x and x.
Okay.
Again, we know the signs are opposite. So I got a plus minus or a minus plus. Again, I'm looking at factors of 12. Only this time I've got to produce a middle term of plus 4x. Well, how am I going to do that? Let's see.
6 and 2?
6 and 2. Yeah, and the 2's got to go here, and the 6 has got to go there. Because minus 6x plus 10x is plus 4x. And that's what I've got to do. Whenever you're factoring, the goal is kind of to produce the middle term. Okay. In other words, once you figure out how to split up the 5x squared, then the rest of it is how do you produce that middle term of plus 4x. And we've done it here. Okay? Now, factor the upper right. Split the x's up. What are they?
2x and x.
Okay. Signs are opposites. So it's either minus plus or plus minus. Factors of 2, there are not very many. There is 2 and 1. And notice that produces my middle term of 3x. With me?
Yeah.
Bottom. Factor that. Every one of these is merely factoring a quadratic. Now, one of the things I can be fairly sure of is that one of these terms is going to match something else that I've already written down, because these problems are all about canceling. Well, how about minus 4 plus 1? That produces that minus 7x term. So our original problem turns into this. Now go to town canceling. That cancels with that. That cancels with that. So I'm left with, in the upper right, 5x plus 3 times 2x minus 1 all over 5x minus 6 times 2x plus 1. Now, believe it or not, you cannot do anything more with that. You can't do anything with the 2x minus 1 and the 2x plus 1. Those are completely different terms. And I cannot do anything with the 5x plus 6 over the 5x minus 6. Those are also completely different terms. So this is what the book should show as the answer. Let's make sure it does for 75. Especially after missing the last one. And notice the upper right is the same as they show for 75.
Mm-hmm.
Exactly. And they will always simplify if it's simplifiable. So the fact that they don't simplify this any further means you can't do it.
Okay.
Notice also that they do not multiply the numerators and denominators to put it back into quadratics. In other words, they leave their answer in factored form. That's because it's the best way to leave an answer. We never know what we're going to do with that answer. Are we going to do something else with it? Well, if whatever we're going to do with it would be easier done if it's in factored form than if it's not. In other words, if I were to multiply that back together and produce a quadratic, then the next step I might have to go back in and factor it. So always leave your answers in factored form if that's what you get. Alright, let's see. We got no more time left, so I'll make a note that we got through 75. All right, Madison? Talk to you next time.
All right, bye.